Let us look at this question here. The items refer to the following diagram. And here you would have seen we have a right angle triangle. The right angle triangle there, RQP. Now, what they give us, they tell us that angle Q, which is the right angle triangle, and that is equal to 90. Angle PQ, the length PQ, it's 50 cm. QR is 130 cm. They're asking you to find tan PRQ. Tan PRQ would have been the angle at R. Now, using the trigonometric ratio, sine is equal to opposite upon hypotenuse, cos is equal to adjacent upon hypotenuse, and tan is equal to opposite upon adjacent. They're asking us for tan PRQ. Hence, if we were to use the trigonometric ratio for the tan identity, we would have seen that the opposite side would have been, or by substitution, tan theta is equal to the opposite, which would have been 50, upon the adjacent being x. How do we know the adjacent being x? Because the longest side is always pointing to the 90 degree, which is called the hypotenuse side. Therefore, our solution there for that first question would have been tan PRQ is equal to 50 upon x. Hence, the solution is A. Now, as we move to the second question, the item referred to the diagram below, and this is a very interesting diagram where the question reads, the diagram above, not drawn to scale, shows the angle of depression of a point X, the point X from Y. The depression of a point X from Z. From Z meaning the angle should be at Z looking down. Now that angle that is formed there is 30 degree by depression. And said that if X is 10 meters from a point Y, please note the point or the line XY to ZY forms an angle of 90 degree, hence we're dealing with a right angle triangle. Now they want the height of YZ in meters. To find this, we need to understand an important concept in geometry. And what is that concept? If you look in the diagram given there, you would have seen a Z being formed. And we know Z angles are alternate angles. And what do we mean by Z angles equal to an alternate angle? It means that these two angles are equal. Hence, for us to find that length there, ZY, using another trigonometric ratio, and those trigonometric ratio again, the sine ratio is opposite upon hypotenuse, the cos ratio is adjacent upon hypotenuse, and the tan ratio is opposite upon adjacent. Now looking at these trigonometric ratios, we need the length ZY. Now for us to find ZY or YZ, we were given an angle which is 30 degree. We were given which side to the angle, it's the adjacent side, which is 10 meters. And we need the opposite side, which is unknown. Now looking at what is given here, the trigonometric ratio that we need to use would have been the tan ratio, which would have been opposite upon adjacent. And by substituting, tan theta would have been the opposite side, which is unknown, and the adjacent side is 10 meters. Therefore, for us to find that length there, this would have been 10 tan 30 degree, which would have equal to x by substitution. Hence, our solution again would have been A. Interesting question. Which of the following statements best describe the properties of an equilateral triangle? And there we have 4 options. Now, in geometry, we would remember types of triangle, and when we are mentioning the name equilateral triangle, there are certain properties we know. Equilateral triangle, the 3 sides are equal. So right there you would have seen number I, or letter I. All sides are equal. That is one property. Additionally, for an equilateral triangle, all the included angles are equal. We look at number 2i there, all the angles are equal. Do we know any other property at this moment of an equilateral triangle? No. Hence, our solution by going through the options there, for an equilateral triangle, we know that 1, all the sides are equal. 2, all the angles are equal. Hence, our solution would have been A. As we move to the 4th question, this item refers to the diagram below. And here we go, because we're dealing with geometry and trigonometry in this session. We have another right angle triangle, and mind you, we're identifying these types of triangles from the time we see the 90 degree. That's how we know it's a right angle triangle. And the question reads, in the right angle triangle, additionally they mention it above, which of the trigonometric ratio is equal to 4 upon 8? And they give us these dimensions, 4 cm, 8 cm. Now, in reference to 2 angles given there, we have y and x. Using the trigonometric ratios again, of writing them, sine is equal to opposite upon hypotenuse, cos is equal to adjacent upon hypotenuse, and tan is equal to opposite upon adjacent. In writing what is given, they're asking us for 4 upon 8. And in that triangle here, 4 upon 8 would have been in reference to angle x. So even though they label the triangle with y, we need that ratio 4 upon 8. And 4 upon 8 really represents, in reference to the right angle triangle, we're talking about the sine ratio. How do we know it's a sine ratio? The sine ratio tells us that x has 2 sides we're looking for, the opposite side and the hypotenuse side. And if we look at that right angle triangle, you would have seen in the right angle triangle, x is referencing to opposite, which is 4 cm, and the hypotenuse, which is the longest side away from the 90 degree, it's 8 cm. In writing this, it would have been sine theta is equal to 4 upon 8. So which ratio we're looking for? It's sine x, and that's our solution. So our answer here is A. As we move to another concept in trigonometry and geometry, here we're looking for, the question reads, the image of a point P minus 2, 3 under a translation 3, 4 is, now in translation vector, there's a concept we use which says the starting point plus the translation equals the end point. Now, in movement of objects in geometry and trigonometry, there are several and different types of relationships and functions we use. The mere fact they mention translation, it's only applicable to this formula, which reads the starting point plus the translation equals the end point. Now, in substitution here, they give us point P, and point P is minus 2, 3. And they want us to find the endpoint given the translation vector 3, 4. So really, what they're asking us to find there, the image point, and they mention it, the image of a point. So the image of that point, by applying the addition of the values of x, we would have had 1, 7 being our translation vector. Hence, our image value is 1, 7. So the image of minus 2, 3, which undergoes a translation of 3, 4, give us an image value of 1, 7. Hence, our solution would have been D. Item refers to the following right angle triangle. Kindly take note, they're mentioning those key terms in geometry and trigonometry. Right angle triangle, an angle is given there. A length is also given, and that length given in respect to this right angle triangle is the hypotenuse side. And how do we identify the hypotenuse side? Again, wherever the right angle is pointing to, that is our longest side, called the hypotenuse side. In the triangle not drawn to scale, angle BAC equal 30 degree and AB equal 40 meter. The length AB, which is 40 meter, it's opposite the 90 degree, which is the hypotenuse side. That is the longest side of the right angle triangle. Now, they're asking us to find the length of BC in meters. BC in reference to the right angle triangle, and the angle given is the opposite side. Interpreting the question and writing what we need to solve the opposite side, the trigonometric ratio we should be using, and why we're using it, it's because it's referencing to a right angle triangle. Of being the sine ratio, opposite upon hypotenuse, the cos ratio, adjacent upon hypotenuse, and the tan ratio, opposite upon adjacent. In writing what we want to solve this question, we would have to use the sine ratio, which is opposite upon hypotenuse. And why we are using opposite upon hypotenuse is that we were given the angle. We are required to find the opposite side, which is BC, and the hypotenuse side is given as 40. Hence, for us to find BC, BC would have been 40 times sine 30 degree, and that solution would have been A. A surveyor sets up his instruments 12 meters from the foot of a building and records the angle of elevation on the top of a building. Now, interesting question here. What they are saying to us is that the difference between the building and the surveyor, it's 12 meters, or the distance between the two of them is 12 meters. They're telling you that when the surveyor is viewing the top of this building, the angle of elevation is formed when we're viewing in an elevated position. So, when we are mentioning angle of elevation, it's very important for us to know where exactly we're looking from. And this surveyor is looking from a point which is 12 meters away from the building. They're asking us to find an estimate of the height of the building is obtained by using which calculation? Now, I want you to take key note, the height of the building. It's from the base of the ground to the top. So we're looking for this total height here. Now, that total height could be found by two things we'd have to do. First thing, we'd have to find from the eyesight of the surveyor to the top of the building, because the surveyor is standing at a height which he measures to be 1.6 meters. Now, for us to find this distance between the height of the surveyor and the top of the building, Again, we're given an angle of 40 degrees, being his angle of elevation. The distance between himself and the building is 12 meters. Now applying one of the trigonometric ratio, because the horizontal line of sight to the building and the building wall makes an angle of 90 degrees. So there we have a right angle triangle. If we were to cut this out, the distance between the surveyor and the building is 12 meters. The angle of elevation is 40 degrees. We need the opposite side in reference to this triangle. For us to find the opposite side, given the right angle triangle, again, we'd have to apply a trigonometric ratio. And it's very important for us to remember and write these trigonometric ratios so that we'll know which one exactly we are using and how and why. The sine ratio, the cos ratio, and the tan ratio. Now, if we want the opposite side given an angle, and we want the opposite side of the angle, and we were given the adjacent side, right there we could see which of the trigonometric ratio with the values or the extrapolated known in the question, which one of the trigonometric ratio we could use. Now, can we use the sine ratio? If we look at what is given, we were given the opposite on the hypotenuse side. Can we use sine? No. So right there and then we know we cannot be using the sine ratio. Can we use the cos ratio given the adjacent and the hypotenuse and the extrapolated value? No. Hence, our value between, or the trigonometric ratio that we need to use is the tan ratio. And applying the tan ratio, tan theta would have been opposite upon adjacent. In substituting, tan 40 would have been opposite upon 12. To find our opposite side, it's 12 times tan 40. Now, if we were to put that in our diagram, you would see this does not include the height of the surveyor, which is 1.6 meters. All that we were finding there was the height of the surveyor to the top of the building. And that is how we arrive at 12 tan 40 meters. That's the height here. But we need to include the height of the surveyor to have the total distance from the base of the building to the top of the building. Therefore, the total height of that building would have been 12 tan 40 plus 1.6 meters. And our solution there would have been D. This item refers to the following right angle triangle. And there in trigonometry, you would have been hearing these key terms. Right angle triangle, very important. We need to know where the right angle is. In reference to this right angle triangle, we were given some lengths. And the question reads, in the triangle ABC not drawn to scale, AB is 17 cm, AC is 15 cm, and BC is x cm. The value of x in centimeters is. Now here we have a different proposition that this question poses. We were not given any acute angle for the right angle triangle to find a side. In preference, we were given two sides and we need another side. So what is the concept to be applied for us to find an unknown length given two sides of the right angle triangle? And you would have remembered another concept in geometry here. It's Pythagoras Theorem, given two sides and an unknown side is required from the right angle triangle. In writing Pythagoras in reference to this triangle here, we always go for the side where the right angle is pointing to, and that is our longest side. It becomes AB squared by Pythagoras should equal to AC square plus BC square. For us to simply remember Pythagoras again, Pythagoras says the sum of squares on the hypotenuse side is equal to the sum of squares on the two sides, or the two included sides, that completes the right angle triangle. By substituting values using Pythagoras there to find the length BC, we would have had AB square, which is given, and that is 17 cm, should equal to AC square, and AC square is given as 15 cm, plus BC, which is not given, and that is what we need. In computation, this would have been 289 cm square should equal to 225 cm square plus BC square. In transposition, 289 cm square minus 225 cm square would have equal to BC square, which is our unknown length that we want. In further computation, this would have given us 64 cm square, which is equal to BC square. But we don't want BC square, we want the length of BC. Hence, in further transposition, the square root of 64 cm square will give us the length of BC. Hence, BC would have been 8 cm. Our solution there would have been B. In triangle PQR, angle P is x degree and angle Q is 2x degree. What is the size of angle R? In geometry and trigonometry, these are principles we have to remember and understand, that the sum of angles in a triangle is equal to 180 degrees. If you were to put that up on a diagram and label triangle in reference to PQR, and input what is known, they tell us that angle P is x degree, angle Q is 2x degree, and they want the sum of angle R, which is unknown. But because we are dealing in x, we don't know the value of, or an exact value for angle R, but we could write it using algebraic principles to understand and find the value of R. Now, by using the sum of angles in a triangle where angle P plus angle Q plus angle R equal to 180 degrees, we could substitute and represent algebraically what is the size of angle R. Angle R could be found by using P, which is x, plus Q, which is 2x, plus R, which is unknown. However, we know that when we add P, Q, and R, this sum is equal to 180 degrees. So in writing it algebraically, we could say x plus 2x plus R should equal to 180 degrees. 3x plus angle R is equal to 180 degrees, where R is equal to 180 degrees minus 3x. Hence, our solution there would have been D. The item refers to the following diagram. And there you would have seen the question keep mentioning in trigonometry and geometry, when we're dealing with a shape, what shape are we dealing with? They tell us that this is a right angle triangle. In addition, they show us the right angle triangle. Oh, this question is asking us to say in the right angle triangle, tan theta is equal to what? Now, interestingly enough, in this question, they have given us all the sides of the right angle triangle, but they're asking us for tan of an angle. And the angle they're asking us for has reference point, and those reference point in relationship to the tan ratio would have been opposite upon adjacent. Now this is an interesting question. If you look at this triangle, it's very important, and that's why I keep telling learners, you need to understand the concept that involves the shape. And you would have heard me mentioning, and your teachers have been mentioning this to you, in a right angle triangle, we always try to identify the longest side, especially when we're going to be using the right angle triangle for the solution. Providing we know that the other two sides we can really represent and interpret differently, or in relation to the included angle, or whichever side you're asking us for. Now, we look at this right angle triangle, and we would have seen that the 13 there is the hypotenuse side. Additionally, when we look at it, we could see the 13 is greater than 12 and 5, hence it is the longest side. So we identify the hypotenuse side because we need to know these stuff. If we don't know them, we're going to be making mistakes in these questions, and we don't want to get any of them wrong. In reference to the triangle and the angle, the side opposite the angle is always the opposite side. Hence, 5 is the opposite side. So the remaining side here is the adjacent side. I do this because it's very important. Many times we're making mistakes. Students would look at the side opposite the angle is the opposite side, and the side on the base of the triangle, and base in this case appears to be 13, which would have given us the wrong solution. So we need to be very careful when we are solving questions like this in writing the tan ratio, because they're asking us to represent tan theta. The opposite side would have been 5 upon 12. Hence our solution there would have been B. In the diagram, AB and CD are parallel. And in geometry, we represent parallel lines, or we identify parallel lines by those two arrows. The question reads, which of the following describes the relationship between x and y? And x and y are those two included angles. Now, in geometry and trigonometry, we have a principle called transversal, and there is a theorem that says any transversal cutting a parallel line, the alternate angles, or the z-angle form, are equal. And here you would have seen the transversal is cutting the line AB and CD. And the two included angle, or the two angles they are making reference to, are x and y. Now x and y, they are alternate angles. And how do we know they're alternate angles? If we were to use a pointer and trace the letter Z, you would have seen Z is formed precisely including angle x and y. And if it's formed precisely including x and y, we could say x is equal to y, which are alternate angles. And alternate angles are equal angles. Hence, our solution for this question would have been B. The question reads, a boat traveling on a bearing of 270 degrees, in what direction was it traveling? 270 bearing. And fundamental question that we'll be using in the airstrip. From time we hear of a boat or an aeroplane, we would have been hearing the co-pilots or the pilots mentioning bearing. So what is bearing and how do we use bearing? We have to remember, or we have to understand, to start somewhere, we need a reference point. And in bearing, the reference point is the true north position. And the true north position, when we are measuring bearing, goes from true north in a clockwise direction. So, if we want to represent, as the question is asking us, a boat is traveling on a bearing of 270 degrees, in what direction is it traveling? We're looking for a direction. And if we were to represent 270 degrees on a plane, and concepts of where exactly this 270 degree lies, by subdividing 270 into 90s, we would see we have 390 degree there. 390 degree would have given us 270 degree. Now, 390, how we represent 390 on the Cartesian plane, and to give us a direction, measuring from the true north coming around, from north to east would have given us 90, from east to south would have given us 90, from south to west would have given us 90. So, 390, when we sum it, the direction this boat is traveling is in a westward direction, hence our solution is A. A ladder 5 meters long is leaning against a vertical wall. The foot of the ladder is 3 meters away from the wall. How far up the wall does the ladder reach? This is a very interesting question. Now, in geometry, reading is one important concept. Representing what we read is very, very important, because when we represent it, we get a clearer picture as to what the question or what exactly we're talking about in geometry. Now, in representing this question, this is what they said. We have the ground, which is horizontal in nature, and we have a vertical wall. Now, the vertical wall towards the ground would make an angle of 90 degrees. Horizontal, vertical, where the two of them meet, that angle form is 90 degrees. Here's what they said. They said a ladder 5 meters long. So there we have a ladder from the ground resting on the vertical wall. And they said the distance, the ladder, the foot of the ladder to the base of the wall is 3 meters. They're asking us how far up is this ladder reaching? If we were to take out what we know here in this question, we know a couple of things. The triangle we're dealing with, it's a right angle triangle. The ladder is 5 meters, and there we have the side in reference to the ladder. It's the hypotenuse side. The base of the ladder is 3 meters, and that is the distance away from the foot of the ladder to the vertical wall. They're asking us how high is this ladder reaching up this wall? Now, using Pythagoras, and why do we use Pythagoras? Here we do not have an angle. We are given two sides of the right angle triangle, and we need another side. So by applying Pythagoras, we should be able to find the height of that ladder, or how far the ladder reach up the wall. Again, applying Pythagoras Theorem, we take the longest side, we square it, and again, how do we identify the longest side? Where the right angle is pointing to, that is the longest side. Should equal to the sum of squares of the other two sides. Hence, in computation, 5 squared would have given us 25, 3 squared would have given us 9. Transposition, taking a positive over the equal sign. How far this ladder is meeting up the wall, it's 4 meters. So our solution there would have been A. In the triangle, the value of x is, and there we have an interesting concept in geometry which involves a triangle. When we look at this triangle, right away we could say this triangle is not a right angle triangle. And how do we know that? Because the right angle is not included. So we need to find other clues as to what type of triangle we're dealing with, because here we were given an angle and we were asked to find an unknown angle. Now when we look at this triangle, a special name is given to this triangle, and how do we know that special name? Is when we look at the geometrical symbols of representing a geometric shape, we could identify the name. Now, the name of this triangle here is an isosceles triangle. And how do we know that? We know an isosceles triangle has two equal lengths, and it's represented. It is represented by those two symbols or those two markings on the triangle. Additionally, in interpreting this question, if we have two sides and it's an isosceles triangle, we know that two sides and two angles are equal. Hence, we could make that deduction to say if one angle of the isosceles triangle is 40, therefore another angle should be equal to 40. Now, in finding the value of x using the sum of angles of a triangle, x plus the two known angles now should equal to 180 degrees, the sum of angles in a triangle. Therefore, for us to find the value of x, it would have been 80 plus x should equal to 180, where x is equal to 180 minus 80. The value of x is 100 degrees. Our solution here is C. All right, this is an interesting question when we are reading, so that in geometry, like I've been saying, there are certain concepts we need to understand, and reading the question really gives us what concept they're talking about. Here's what the question says. The item refers to a diagram below of a construction. So we're talking about a construction question. With center A, there we have a point A, an arc BC. So we're placing our compass point at A and we're scribing an arc. Same length, they tell us. So this is B, this is C. We don't know how far it's BC. They say with the same radius as AB is the radius that we're going to mark PQ with. They're asking us what is the measure of angle BAC. That is this angle here that we just constructed. And in geometry, that is how we construct a 60-degree angle. Hence, our solution there would have been C. Under the translation 2 minus 3, we have a translation 2 minus 3. The image of a point, 3 minus 5 is equal to, so we're looking for the image value given this question. In translation vector, starting point plus translation equals the end point. And that's the rule that we're going to be using all the time when that key term there, translation, is mentioned. To move an object through a translation, we have to start somewhere using the translation vector, then we arrive somewhere. Or we could arrive somewhere by a translation vector. Hence, we could find where we're coming from. In substituting what we know, we were given a starting point, which is 3 minus 5. And we were given the translation vector of 2 minus 3. So we need the image value, which would have been the end point. In summing the values here, we would have had 5 minus 8 being our endpoint using the translation vector T, 2 minus 3. So our solution would have been D. Please be careful with addition and subtraction of directed numbers. I know we love our positive values, but we need to be very careful with our negative values as well. Minus 5 plus minus 3, we're continuing along the negative path, so we're summing them. Would not be minus 2 or positive 2. It's a minus 8. So our solution here is 5 minus 8. This is another interesting question. They said in the diagram, the translation by which AB is mapped onto A prime, B prime is represented by. So here we have a line segment. AB mapped onto A prime, B prime by some translation. Now, they're asking us to find that translation. We were given the points for A prime, B B prime. Now A is given as 2, 5. A prime is given as 4, 6. B is given as 5, 7, and B prime is given as 7, 8. In applying the translation formula, starting point plus translation equal endpoint, we would have seen using either A or B, but for clarity we're going to use both A and A prime, B and B prime to understand, irrespective of which one we're using, the translation vector would have been the same. Using A and A prime to find the translation vector, A would have been 2, 5 plus the translation, which we don't know, should equal to the endpoint, and the endpoint which is 4, 6. In transposition, to find our translation vector, the translation vector of txy in this case, using A and A prime, would have been 2, 1. By subtraction, 4 minus 2, 6 minus 5. Now, assuming we did not use A and A prime and we're using B and B prime, will we have the same translation vector? Let us try it. Starting point plus translation equals endpoint. Now, our starting point here would have been B, and B is 5, 7. So we're using B and B prime. We don't know the translation vector, which is an unknown quantity, and we know where B arrives. B arrives at 7, 8. Now, in finding our translation vector txy, our translation vector txy would have been 2, 1. Hence, irrespective of us using A prime or B prime to find our translation vector, the solution would have been the same. Hence, our solution for this question, using either A prime or B prime for finding the translation vector, would have been B, which is 2, 1. From the diagram above, sine C is, and there we have a interesting question. Very important for us to look at this diagram and see exactly what are we dealing with. When we look at this diagram, we would have seen that this diagram here represents a right angle triangle. And in labeling this right angle triangle, again, I keep emphasizing we always identify that longest side so that it will give us an easy referencing point. Additionally, they give us two sides of the right angle triangle. But here's what the question is asking us for. The question is asking us for sine C. And sine C, or the sine ratio of a right angle triangle, is opposite upon hypotenuse. And if we look at this triangle here, the opposite side in this right angle triangle is unknown. But we were given the two other sides of the right angle triangle. So if we could find that side, we can be able to find the size of that angle C. How do we do that? Now, in a right angle triangle, knowing two sides and we need an unknown side, we can go apply Pythagoras Theorem. And this is one of the triangles that we've been using for referencing in many of our examples. It could have been easily seen that the opposite side of C is 3. However, let us not take anything for chance and find or identify what is this opposite side. In applying Pythagoras Theorem, there we go again, using the longest side, and we square it, should equal to the sum of squares on the two opposite sides, or the two other remaining sides. In computation, 5 square is 25, 4 square is 16, and we need to find the remaining side, which is unknown. Now 25 in transposition, finding the remaining side. But we don't need the remaining side square, we need that side. So that side there, which would have been 3. Now, we have all the sides of the triangle, with the side opposite C known. And in applying trigonometric ratio sine theta, which is what they're asking us for, opposite upon the hypotenuse, the sine ratio of this triangle would have been 3/5. Hence, our solution there would have been A. In the diagram above, AB is parallel to EC. We need to look for these key terms and their symbol representation. Parallel lines are represented with those 2 arrows going in the same direction. Now, in labeling what they give us, the value of the angle BDE is, now we're looking for BDE. We're looking for this angle. Now this line segment DE is a transversal, and there's no alternate angle looking at this question here that is required. However, another interesting concept with a transversal and the parallel lines principle is that the two included angle, that is this angle and this angle, they are called co-interior angle. And co-interior angle, when we sum them, that is when we sum ABD and BDE, it's equal to 180 degrees. So if we know one of them, can we find the remaining angle? Yes, we can. We can find them because we know angle ABD is equal to 40 degrees, but we don't know angle BDE, which is the required angle. But when we add the two of them, it's equal to 180 degrees. So, in writing an algebraic equation, 40 plus x should equal to 180. X would have been 180 minus 40. X is equal to 140. Hence, our angle BDE is 140 degrees. So our solution here is C.